everybody. Thanks for watching. In this lesson, we are going to be finding the area of regular polygons. Now, this is a really good lesson because it reviews so many of the things that we've learned this year in geometry. So first of all, some definitions for you. The first few are review. A regular polygon, that is a polygon whose sides and angles are congruent. So all the sides are the same length, all the angles are the same measure. And then an inscribed polygon, that is when all of the vertices are on a circle. You can circumscribe a circle about any regular polygon. So we use that idea to help us find the area of regular polygons. A new term is an apothegm. An apothegm is the distance from the center to any side of a polygon. So if you draw a line, I'm getting my pen working. So if you draw a perpendicular length, that would be the distance from the center to the side. This is the apothegm. So this would be an apothegm. Notice that doesn't go all the way to the circle, so it's not a radius. It's called the apothegm. So then there would be one here, and one here as well. Now, the next thing we want to look at is how many congruent triangles are there if you draw the radii. So here's the center. Here we have 6 sides. So if I draw a segment of a radius from, so that's a segment from the center to the vertex. Okay, so there's a triangle, and now we will draw a segment to each vertex. So how many do we have? Well, 1, 2, 3, 4, 5, 6. If there are 6 sides, there would be 6 triangles. All right, so in the diagram, ABCDE is a regular pentagon inscribed in circle F. Find each angle measure. I'm going to hop back to this slide here. So let's think about in this particular hexagon, what would be the measure of each central angle? So thinking that if this is a circle, right here, if we inscribed a circle, circumscribed a circle about it, okay, what would be the measure of the arc? Well, this would be 360 degrees all the way around, and we're breaking it up into 6 angles, so 360 divided by 6. So each of these angles would be 60. All right, so let's go back to this problem. We have a pentagon. So in a pentagon, if we were to draw all of the triangles, okay, there would be 1, 2, 3, 4, 5. 5 sides, 5 triangles. So to find the measure of one of the angles, we would take 360 divided by 5, which is 72, I believe. So this angle right here is 72. Okay, so the measure of angle AFB is what they're asking us for first. That would be 72 degrees. Oh, my pen is acting up this morning. I don't know if it's quite awake yet. So 72 degrees. Now it says, what is the measure of angle AFG? Well, AFG, that's this one right here. So that would be half of 72, which is 36. And the next one says, what is the measure of angle GAF? So from G to A to F. So that's this one. Well, if this is 36 and this is 90, we'll take 180 minus 36 minus 90, and we get 54 degrees for that one. All right, so find the measure of the central angle of a regular polygon with a given number of sides. Round answers to the nearest tenth of a degree if necessary. So if it has 12 sides, if the polygon has 12 sides, we would take 360 divided by 12. So each central angle would be 30 degrees. In the next example, if we have 16 sides, we take 360 divided by 16, and you'd get 22.5. In the next one, we want the measure of the central angle. You take 360 divided by 40, and then you do 360 divided by 21 for that one, okay? All right, now let's move on to the next example here. It says in the diagram, WXYZ is a square inscribed in circle P. Identify the center, a radius, an apothem, and a central angle of the polygon. So the center of the circle is point P. A radius, let's see, we have a few of them we could choose, would be segment PY, or we could also use segment PX. Then we need an apothem. Remember, an apothem is a segment that is goes from the center of the circle to, it's the perpendicular length from the center to the side of the polygon, so that would be this, segment PQ. And a central angle of the polygon. Well, a central angle, remember, is formed by 2 radii. So it would be this angle right here. So it would be angle XPY, or you could say YPX. So that's a central angle. And there would be, there are 4 sides. So you would have 4 central angles, 1, 2, 3, 4. So each of those would be 360 divided by 4 is 90. Each of those would be 90. And then each half would be 45. All right, so just to review, you do need to know the sides or the names of your polygons for this, of your regular polygons. So a 3-sided quadrilateral is, not 3-sided, let me start again. 3-sided polygon is a triangle, 4 sides is a, should be a, well, it would be quadrilateral, but if it's regular, it would be a square. 5 sides is a pentagon, 6 sides is a hexagon, 7 sides is a heptagon, 8 octagon, 9 nonagon, 10 decagon, and 12 is dodecagon. This one has 11 sides, so we call it an 11gon. So if it's not one of these, we just put the number and say the word gon behind it. All right, now to get into this lesson here, to what we really want to learn here is to find the area of a regular polygon. So these are the steps that you want to do. So you might want to write these steps down and just refer back to them, because we do have a number of steps to do. So the first thing you want to do is find the central angle measure. So this here we have 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. So put a point at the center. And we want to draw a triangle. Okay, so first we're going to find the measure of the central angle. So we would do 360 divided by 8, and that gives us 45. So this angle is 45 degrees. Now we drew the triangle and we want to label it. So that's 45 degrees. Now what do we have to do next here? Find the base and the height. Well, in this problem, we weren't given any length, so I'm just going to say, let's say that they told us that this was 3. So I'm going to give us a little more information, because at this point, we wouldn't have enough information. So let's say this side is 3. So what you have to do now is you have to find, this gives us the base, but we're going to have to figure out what the height of that triangle would be. So I'll call that x. That way, what we're going to do is we're going to find the area of one triangle and multiply it by 8. Okay, so if we find the area of one triangle, we know that this would be 8 congruent triangles, so we multiply by 8. So this length would be 1.5. And in this case, I would use trig, because I know that this angle is half of 45, so that's 22.5. I know that this is the opposite. This is the adjacent. So that would be a tangent problem. So the tangent of 22.5 equals the opposite over the adjacent. And then we would cross multiply. So x tangent 22.5 equals 1.5. And then divide. See what I said? We're getting a lot of good review here. So that would be 1.5 that would be 3.6 is about equal to 3.6. So the height is 3.6. All right, you know now the base of the triangle is 3, the height is 3.6. So we are going to find the area of the triangle. So always write the triangle, 1/2 base times height. So the base is 3, the height is 3.6. Now, we are looking for the area of this whole triangle. So you want the whole base when we do this. So the base is 3, the height is 3.6. And so we multiply those out. And you get 5.4. And that's the area of one triangle. And again, we have 8 triangles here. So you take that and multiply it times 8. And that will give you the area of the whole thing. 43.2, and area is units squared. Okay, so like I said, we have a lot of steps, but we've learned how, we know how to do each of them individually. Now we just have to put those all together. So now let's do another problem. You're decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon, which means, again, you have 8 sides, all the sides are congruent, all the angles are congruent, and you have 15-inch sides and a radius of about 19.6. What is the area of the covering? So first of all, we're going to draw the triangle here. Now, I think it's kind of hard sometimes to work with the triangles inside the big figure, so a lot of times I will draw my triangles out and then label it. So all of the sides are 15, so this would be 15. The radii are 19.6. Okay, so each of these would be a radius. And so we need the height of this triangle. So I'm going to drop that in and call it x. All right, so we have some options here. We could start out by figuring out this central angle, which we have 8 sides. So 360 divided by 8 is 45. So this is 45 degrees again, and then this would be 22.5. Sorry, that's kind of hard to see. But we don't actually need to use the angle for this one because we do know the length of 2 sides, so we could use the Pythagorean theorem. So if the whole thing's 15, this would be 7.5. And so, like I said, we can do the Pythagorean theorem to find your missing length. So c squared equals a squared plus b squared. The hypotenuse is the c, and one of the sides is 7.5, the other one is x. And now we can solve that. So 19.6 squared is 384.16. That is 56.25. Okay, so now we're going to do 384.16 minus 56.25. We get 327.9. And we're going to take the square root of that, which is about 18.1. All right, so we know now the base of the triangle, we know the height. So let's write down the formula for area. And again, we did determine right away that this is a 45-degree angle, and then the central angle is 45, and this is 22.5. So you could have used let's see, this would be the adjacent. You could have used one of the trig functions. This is the opposite of the hypotenuse, so you could have used trig to find x instead of the Pythagorean theorem. So either way you would like will work. All right, so the base, the whole base is 15. The height is 18.1 divided by 2. And that's 135.75. So that's the area of this triangle. And we have 8 triangles. So we have to then, at the end, multiply that by 8. So it's 1,086 inches squared. Okay, let's do another one. So here we are going to find the area of, let's see, what's our shape? This is a hexagon. There are 6 sides. Okay, so we need to determine what, let's see, we actually wouldn't need to find the angle because again, you have 2 sides of the triangle, so you could use a Pythagorean theorem to find this side right here. So I'm going to call that x. So we'll use a Pythagorean theorem. C squared equals a squared plus b squared. Again, remember guys, you could determine what this angle is. Take 360 divided by 6. So this is 60, which would make this 30. And I guess that's what I did when I did it in my notes. I kind of like that better. Let's do it that way. But again, you could do the Pythagorean theorem here. You could do 20 squared equals 10 root 3 squared plus x squared. You want to first multiply 10 times the square root of 3 though, before you put it in the Pythagorean theorem. But if this is 60, this would be 30. And we want to find x, and so that would be the opposite. And let's use the hypotenuse because that's a nice number. And so that would be opposite, and hypotenuse would be sine of 30 equals x opposite over hypotenuse. And so x equals 20 sine of 30. And you get 10. Another thing, folks, to remember, this is a 30, 60, 90. And so the short leg is half of the hypotenuse. So you also could have just looked at that and said, oh, I know my 30, 60, 90. So if this is 20, this is 10. Which means that this whole base would be 10 and 10. So this would be 20. And that's 10 root 3. So now we have enough information to figure out the area of the area of that triangle. So base times height divided by 2. Your base is 20. Your height is 10 root 3 divided by 2. And we'll just type that into our calculator. 20 times 10 times the square root of 3. This is a times between there, folks. And we'll hit equals and then divided by 2. That gives us 173.2. And that's the area of this triangle. And if we have 6 sides, that would mean there are 6 triangles. So we have to multiply by 6 to get our final answer. So we get 1,039.2, and that would be area, so it's units squared. All right, we'll just do one more in this lesson, and then I'll do some problems from the worksheet for you. So let's see, we have a regular nonagon. Remember, nonagon means there are 9 sides inscribed in a circle with a radius of 4. Find the perimeter and the area of the nonagon. So we're doing 2 things. We have to find the perimeter and the area. So remember, perimeter is distance around, which means we need to find this length right here. So let's draw the triangle and figure out what our best strategy would be to do that. So these would be the radii, and we don't know the height of the triangle, which remember that's the apothem. So we don't know this side, which we'll call x, or this side, which we call y. So we are going to have to figure out the angle and use trig here. So first of all, if it's a nonagon, to figure out this angle, we're going to take 360 divided by 9. That gives you 40. So this entire angle is 40, which means that half would be 20 degrees. So let's start out by finding y. Y is the opposite, and the side that we're given is the hypotenuse. So that would be sine. So the sine of 20 equals the opposite y over the hypotenuse 4. And we cross multiply, so y would equal 4 times the sine of 20. And that gives us 13.4 approximately. Oh, I wrote that wrong. It's 1.4. Let me erase that. 1.4. So this is 1.4, which means this is 1.4. So this whole length would be 2.8. All right, now let's find this side right here. This is, if this is 20, this is the hypotenuse, this would be your adjacent. Adjacent, we'll use the adjacent and the hypotenuse, which is cosine. So the cosine of 20 equals the adjacent over the hypotenuse. And again, we cross multiply. X equals 4 times the cosine of 20. And that would be 3.8. So the height is 3.8. All right, we're in business. We have the base and we have the height. So the area is equal to base times height divided by 2. The base is 2.8. The height is 3.8 divided by 2. And that would be 5.32 is the area of this triangle. And if it's a nonagon, we would have 9 congruent triangles that are the same size. So you multiply times 9. Don't forget that last step. So 47.9 approximately, and that would be units squared. And then also perimeter. Okay, the perimeter, remember, is the distance all around. And we found that this length is 2.8, and that means all the sides of the polygon are 2.8, so we're going to take 2.8 times 9, and we get 25.2. All right. I'm just looking over my notes here. So we have 2.8. All right, so let's go ahead and look at the worksheet that we're going to be doing for today. So just to get you started here, find the measure of the central angle of a regular polygon with a given number of sides, or description below. So if you have 12 sides, the central angle would be 360 divided by 12, which is 30 degrees. So that's what you do in that section. In this next one, we have a hexagon, and we have to find different angles here. So it says find the measure of angle EGD. EGD would be this whole thing. So we would take 360 divided by 6 sides, which means each of the central angles would be 60 degrees. So then this would be 30. And from there, you can fill out these answers. Okay, let's do a few of these problems together. Let's start with number 12. How about actually number 11? I'm just going to get you started here. Make your triangle. All right. And then also draw in the apothem. So this is going to be x. This length would be 5. And here you can use a Pythagorean theorem to find x. Find the area of the whole triangle. Multiply by 6. On this one, again, we have a lot of information given to us. We're given 2 sides of the triangle. So you can use a Pythagorean theorem to find x. And then you'd have to double that for this length of the whole triangle, and then find the area of the triangle and multiply by the number of sides. Let me move down to this problem right here. Let's go to this one right here. We have 5 sides. We're going to put the center and draw a triangle. All right, so we do not know the height. We only know one side, so we're going to have to use trig. So let me draw my triangle. I like to look at the triangle sitting in the right direction. Okay, so this is the height. We'll call it x. This entire length is 3, so this would be 1.5. So we have to determine first what your central angle is. So again, it's 360 divided by the number of sides, which would be 72. Okay, so this entire angle is 72, which means that this angle is half of that. We want just this one. We're looking at half of it at a time. That's 36. The reason to remember that we want to work with just half of that triangle is because we can draw the line and have a right triangle, and so then when you have a right triangle, you can use trig. So let's label the sides. This is the opposite, and this one would be your adjacent, which is tangent. So we'll use tangent to find x. So the tangent of 36 equals 1.5 opposite over adjacent. So when we cross multiply, we get x times the tangent of 36 equals 1.5, and then divide by tangent 36. So 1.5 divided by tangent 36, that gives you 2.1 approximately. So x is 2.1. Okay, now you know the base, you know the height, so we can find the area of that triangle. Oops, I don't want to go up quite that far. So the area of the triangle, base times height divided by 2. Your base is 3, your height is 2.1 divided by 2. And that gives you 3.2 approximately. And because it's a pentagon, there are 5 of those triangles. You have to multiply by 5. And that gives you 16. So it would be 16 units squared. That would be your answer for that one. Let me just set up another one for you. Number 17. This one, let's see. If we draw a line from the center to the vertices, we're given the apothem in that one. It's 5. So this is a little bit different. So again, I'm going to draw the triangle outside. We don't know what the radii are. So this is 5. So we know the height of the triangle, but we don't know the base. So I'll put an x right here. So the first thing we're going to do is figure out the angle. So 360 divided by the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides on that one. So that's a dodecagon. So that would be 30 degrees for each central angle, which means half of it is 15 degrees. So here we have the opposite. Here we have the adjacent. So again, we'll use tangent. So the tangent of 15 is equal to the opposite over the adjacent. Cross multiply. X equals 5, tangent 15. So it's about 1.3, which means this side is 1.3. And so the whole base is 2.6. So the area of the one triangle, so the base is 2.6, the height is 5, and then divided by 2. I get 6.5. And like I said, we have 12 sides here, so now we have to multiply that times 12 for the last thing. Don't forget your last step. And so you get equals 78 units squared. All right, so there's lots of good practice here for you to do. Let me know if you have questions. You can either email me, we can hop on Zoom. It works really, really well, and I'm happy to help. So let me know if you have questions. Thanks for watching.